Hello, everyone. As always, I do make videos when people ask me questions. And I have a recent question from Emilio that says, can you make a video explaining the different formation of eye specks that look like circles in a circle? Most of them are light, some are dark, and sometimes I see them pass my eyes and move in a sensible movement, like someone will walk around a corner and I see the different orb, circle in a circle right before. Can you further explain this? Yes, I can further explain this. Okay, well, our eyes are made of cells, and each cell represents light. Light in many different ways. The only light we're able to observe is the light in the electromagnetic spectrum that is visible. Our eyes have multiple functions, and some people have the gift of seeing higher colors. Not everybody has this gift. Now, when we're seeing circles within circles in our eyes, there's many different various factors. A lot of germs, a lot of microorganisms can rest on and in your eye, floating there like any microorganism would do, and it would seem like we're seeing these things. Other things is electromagnetic radiation. Too much exposure to TV, too much exposure to video games, cell phones, computers, tablets. Everything will put a strain on those cells in the eye that observe and absorb and translate visible light. The other thing is alcohol, various medications, and various drugs. All these things will impact your senses, and your eyes, your sight is one of your major senses. And when you are under electromagnetic stress, so we say, then you are going to perceive that things are coming and going in a certain pattern. As far as the lower vibrations go, the vibrations that are not mentioned in the video I'm going to share with NASA that explains the visible light spectrum, those lower vibrations exist multidimensionally, and these things, they are not uh, observed by science as of yet as a credible, viable vibration, because they range anywhere between 0.1 to 2-3 hertz, and a lot of times when we're in deep sleep, our brain goes that low and we are completely gone. So I'm going to put up a video explaining the light spectrum from NASA again. And if you are seeing orbs, or if you are seeing things that you cannot explain, unless it is a consistent, persistent entity that is present for seconds upon end, then it has to do with the light spectrum and the electromagnetic spectrum that you are surrounding yourself with. Music is huge. Music is a vibrational entity on its own, and that's why they recorded 440 versus 432. 440 makes you more docile, more easily programmed, so you can follow orders better. 432 is a natural state of vibration, like my voice. So understand that unless it's there for seconds upon time, and it could be as little as 2 seconds, then it's not necessarily an orb or an orb being. Okay, so if you are seeing these things as you're turning your head, for example, it has to do with smog, electromagnetic smog, and that is very important to you to cleanse yourself or to go outside and be in nature more in order to ground yourself back to the earth. And the way you do that, go to the beach, go to somewhere in the park, take your shoes off, take your socks off, walk around for at least an hour and a half. Just have a good time, relax. And that will gradually remove the electromagnetic smog that's within your senses and possibly give you a chance to heal. Okay, so enjoy the video. NASA put it up, so I do not agree with most of the things they say, but it does explain the electromagnetic visible light. Thank you for watching.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected, and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our Sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.